Okay, good morning everyone. So let us begin today's session. So in this week we learned about classes and objects, access specifiers, constructors, destructors and object lifetimes, copy constructor and copy assignment operator, and constness of classes. So what is a class? A class is a implementation of a type. So a class is mainly a way to create user defined data types. Okay. So a class consists of uh, data members and attributes. Okay. And it has some operations which are also called as member functions or methods. So therefore a class offers data abstraction, encapsulation and object oriented programming. So basically what a class is this, that many a times what might happen is that you might require like you know that C++ provides some built-in data types such as int, float, double, okay. But many times what happens is that we require a combination of these data types to represent something, okay. We might require two or three such data types or two or three such fields. Like let us say that we are describing a car, okay. So a car might have fields such as the model of the car and then the engine capacity, then it might also have the mileage. So a car can be described by 4 to 5 parameters. So conceptually all these 5 parameters they belong together, right? So what a class allows us to do is that it helps us to list 4 to 5 parameters and collect them as one unit, okay. So this is the meaning of the class has data members. Now like this is already useful, but it is even more useful if we can define the behavior of these custom objects, okay. Like let us say that we have made a class for uh, let us say matrices, okay. So we have defined a class for a matrix, okay. Now a matrix has operations like addition, subtraction, multiplication, okay. So we ideally we would like to define those functions as well so that we can define the behavior of the class. So what, like in C++, this functionality, okay, the functionality to combine data members, this is also available in C, okay, in the form of struct, okay, in the form of struct this is also available. But in C++ we can also define member functions, okay, which allows us to define the behavior of the class. So C++ class, it consists of um, data members and member functions. Okay, so combining these two we create a C++ class, okay. So uh, now it's written that classes offer data abstraction and encapsulation. So what does this mean? Uh, it means that a class like this framework, it allows us to do data abstraction, which means that we only expose those data members which are required for external functionality. Like a class might have lots of data members, okay, but some of the data members are only required for internal use, okay. They should not be made public to other classes or other functions, okay, because uh, that might create errors in the class's operation, okay. So class allows us to do data abstractions, which is hide these data members from external functions, okay. And it also performs encapsulation, meaning that the classes data members and their member functions can be defined as one unit. So C++ class is defined by the class keyword. Now we come to objects. So what is the object? So So in this C++ class, we have data members and member functions, but the class that we write, it is like a template. Okay, so let us say that we create a C++ class. I'm just writing. So let us say that we have created a C++ class with attributes and functions. Okay, but this is actually just a template because the attributes don't have specific values assigned to them. Okay, so what we call an object is an instance of the class. So we take this class template and we assign some specific values to the attributes, and that creates a object. So we can say that our object has a uh, initialized attributes. Okay, we can call that. So if we initialize the attributes of the class, then we get a object. Okay, so a class can have multiple objects. So object comprises of data members that specify its state. So once the data members or the attributes, they have been assigned some value, okay, then the object is created. Okay, a specific instance of the class which is created. So object supports member functions that specify its behavior, and data members of a object can be accessed by the dot operator. So if we have an object like, let's say, obj, we can use obj dot x to get a member of the object. We can also call a function of the object like this, dot f. Okay, that way we can call a function. Member functions are invoked by the dot operator on the object. Okay, and this is an important thing. So an implicit this pointer holds the address of an object. This serves the identity of the object in C++. So, and it's written this pointer is implicitly passed to all the methods. So what it means that inside the object, okay, like this keyword, it does not work outside the context of a object. Okay, it is specific to a object. So let us say we have written the code for a C++ class. Okay, now inside this code, we can make use of a special pointer called this. Okay, this pointer, okay, this is a special pointer which is available inside a class. So the pointer, it points to the address of the current object. So it holds the address of the object. So we can, like, if we require anything where we require the address or something, then we can use this pointer, and the pointer is implicitly passed to all the methods. So even inside a function also we can use this pointer. Now this is a sample program with a class. So IOStream CMath we are including and doing this. Now we create a class called point. So how do we define it? We write the class keyword and then the name of the class, and then in curly braces we write the data members which are x and y. So here we are assuming that here we are assuming a point in 2D space. So we have two coordinates x and y. Now what is this public? The public means that these data members, they are accessible externally. Like outside the class also we can use the dot operator to access these data members. In case these were private, then it would not be accessible. It would be a compiler error. So now we have defined this point class. Now we define a rectangle class. So again, similarly, we write the class keyword and then we write the name of the class, which is rect, and then we write public to indicate that this is a these are public data members. And now see, now notice the interesting thing. We have 2 points inside the rectangle class. Okay, so we are using this point class inside the rectangle class. So if we are defining a rectangle in 2D space, we require 4 parameters minimum. Either the coordinates of the top left and bottom right, or we can, there is another convention that we can get the center of the rectangle and then the width and height. Okay, so in both cases we require minimum 4 parameters. So here instead of defining, like instead of using the parameters individually, what we are doing is we are using the point class which we have already defined before. So we have two data members, point top left and point bottom right. Okay, and now we are also defining a member function which is called compute area. So what the compute area function is doing is, wait a minute, okay, it is calculating the width and the height and then multiplying them, so it gives you the area, as you know. So we calculate the width and the height and then we multiply them to get the area. Now to demonstrate utility of this class, uh, we have a main function where we define a rectangle. So notice the syntax. So first on the left hand side we are writing rect r. It is very similar to, it is exactly same as how we write int x uh, or float f. Okay, exactly similar, which shows that this is like a data type only, a user defined data type. And then we are in curly braces we are assigning values to each of them. So this will be assigned as how it is defined in the program. Okay, so this 0 2 it will go to the top left point and 5 7 will go to the bottom right. Okay, and now we are, so this will create this r variable which is of rectangle type, and then we write r dot compute area which will call this function. So r dot compute area will return the area of the rectangle, which in this case it's 5 into 5, so 25. So this should return 25. Okay, uh, wait a minute. Okay, now we come to access specifiers. So what are what are what are access specifiers? So in the previous class you saw these keywords. Okay, public. Okay, and there is another keyword, private, and also protected. So access specifiers are these keywords. Okay, so classes provide access specifiers for members as well as member functions to enforce data hiding that separates the implementation from the interface. Okay, so in complex classes, so this rectangle class that we saw in the previous slide, it is very simple. But in complex classes we have uh, in complex, let us say we are creating a class to download some file from the internet or upload some file to some server. Okay, the class will have lots of data members for its internal state. Okay, like it might have a port number, it might have the number of bytes received or the number of bytes sent, all these data members it might have. Okay, but there will be some data members that, like, there will be lots of data members, but we don't want to expose all of them to any external API, because that might cause some problems in the class. Let us say that we have a data member which talks about the number of bytes received. Okay, now if it is accessible publicly, then some other some other function might accidentally modify that number, which will cause an error in the operation. So we would like to hide such members from the outside world. So what we would do is we would make them private, and the things that we want to expose, such as let us say the storage location of the file where it's being downloaded, we can make them public. So the private data members accessible inside the definition of the class, and yes, accessible inside the definition of the class, and public means accessible everywhere. So the member functions of the same class, they can access these data members. Okay, so if you have one class, if you have two classes, okay, and you have some attributes and some functions here, and first let me discuss the public one. So public means that everything is accessible from everywhere. So uh, these functions, okay, they can access the attributes of the same class. Okay, they can also access B's attributes also. Similarly, B's functions, it can access the attributes of B class. It can also access the attributes of A class. Okay, so everything can access everything, and uh, like you utilize, okay, all the variables. But okay, but let us say that the attributes are now private. So in that case, A's functions can access A's attributes and B's functions can access B's attributes, but the this thing is not allowed. Like A cannot access B's and B's attributes cannot access B's functions cannot access A's. Okay. Now public attributes are also accessible from global functions. So unless otherwise specified, the access of members of a class is considered private. So in the previous example, you saw that I defined the class and then I wrote public, okay, public colon, and then the attributes. So if if this public was not written, like let us say I just wrote class point and then let us say I did not write this, then by default it x and y will be private. Okay, unless otherwise some it is written, all the data members are private. Okay, now I come to constructors and destructors. So a constructor is a special function. Constructor is a special function uh, which is called when a class is initialized or a object, like a class is not initialized, but when an object is initialized or object is created. uh, okay, so it is a special method with the same name as the class. So class rectangle, if I inside the inside the class, if I write a function with the exact name as the class, then it is a constructor. Okay, this function is called when an object is created. Like we have a class, then when we create an object, then this constructor will be called. Okay, now similarly we also have destructors, and a destructor is a uh, special function which is called when the object is destroyed or deleted. So after, like let us say, after the program or the finishes or the function finishes, okay, an object is destroyed. Now sometimes if the object has been allocated to heap memory, the object might also be cleared manually. Okay, like we can use the free or the delete method to clear the object. So in those cases also the destructor is called. So it is a special method with the same name as the class, but it has a tilde. So here there is a mistake, there should be a tilde here. Okay, so tilde is this wavy kind of symbol. So the constructor is a function with the same name, and the destructor is a function with same name but with this tilde before it. Okay, now I come to the copy constructor and the copy assignment operator. Okay, so a copy constructor is a special constructor that is invoked when an object is copied to a new object. Okay, uh, so like let us say that we have a class, we have an object of type my class, and we are creating a new object C2, uh, which we are copying from C1. Okay, then this constructor is called, and the type signature of this constructor is this. So you can see that it has the, so the first part, it is the name of the class. Okay, the second part is the, like it is what I mean is that the first part, it is the namespace, which is the which is the same as the name of the class, and the second part, it is the function name, which is again same as the class because this is a constructor, so it will have the same name. What is different is the, what is important is the argument list. So in the argument list we have const, class name, and ampersand. So it is a reference to an object of the same type as the class itself. Okay, now a similar thing as the copy constructor is the copy assignment operator, and this operator is invoked when an object is copied to an existing object. So this is the difference that you have to note. So when a object is copied to a new object, as in this case, then the copy constructor is called. But when it is copied to an existing object, like over here, then the copy assignment of the operator is called. Okay, so here you can see what has happened. We have created two two objects, okay, at the same time, and then we are copying one object to another object. Here what happened was that we have created one object and we are creating another object using the first object, but here both have been created and we are simply copying. Now this copy assignment operator has this type signature. uh, so you can see one difference is that this is not a constructor. Okay, This is not a constructor, this is an example of operator overloading. Okay, so it returns, so this is the class namespace, and it returns a reference to a uh, it returns a reference to an object of my class type, and then we overload the equal to operator. We overload this equal to operator, and it also accepts a reference to an object of my class type. So this is the, so both accept references to the object of my class type, uh, which is the similarity between them. But this one, it does not return anything. This one returns another reference. Okay. So now we come to the exercises. So the first question, it is quite simple. Please try on your own. Like we'll discuss after 2 minutes. So identify all the methods that change the state of the complex objects. Okay, now we'll discuss this question. So um, first you can see that it is a class called complex, and it has some private methods and some public. It has a private section and the public section. So you can see that it has two data members, real and imaginary. So the data members are private. Okay, so they cannot be accessed or modified from outside this class. Okay, you have to use these functions to either access them or modify them. Okay, now the question stated, identify all the methods which change the state of the object. So state refers to the data members. Okay, the collection of data members, like I mean their specific values. Okay, specific values of the data members, they define the state of the object. So if in any question they ask you about the state, it is the values of the data members. So now which of these methods change the values of the members? So obviously the set RE and set IM methods they do, because you can see that RE and IM are being assigned to meaning that their values are being modified. So these methods they change the state. The print method, it does not assign anything to RE and IM, it just prints the value, so this does not modify the state. Next we have the INCR method. Okay, the INCR method, you can see that it this also modifies the state, because it does RE plus plus and IM plus plus. Now you know that RE plus plus will increase the value of RE by 1, and similarly for IM. So the value of the member will be changed. Okay, value of the data member will be changed, which means the state will be changed. So this one it modifies the state. Next we have the INCR RE method. So INCR RE, it you can see that it increments the RE variable, but it does not set it to something else. Okay, so it just increments it and it returns the, it adds one to it and it returns the value. It does not really modify the variable, so it does not change the state. Next we have the IM method. The IM method, it increments the variable. You can see that it is doing plus plus IM, meaning that the IM variable itself is being increased by 1. So this modifies the state. So so that is the solution of this question. And now I'll go to the second question. So what is the output or the error of this piece of code? Okay, now let us discuss. So this is this question is mainly about constructors. Okay, so we have a class called number with a here nothing is mentioned. So this is a private data member. Okay, this is a private data member n, and now we have some public functions. Uh, the public function is the constructor. So number, we have a default constructor. Default constructor means that it accepts no arguments. So there are no arguments, which means that by default this constructor will be called. And then we have a constructor which accepts an argument I. Okay, now the first constructor, which is a default constructor, you can see that it prints 0. It prints 0 and then a space. And then the second constructor which accepts the argument, this this syntax, it's called a uh, I think it's called a assignment list. And then the body of the constructor, it prints the value of n. So this is equivalent to n equal to I, like initializing n with I, and then in the body of the constructor we are printing the value of n. So this is the definition of both the constructors. Now the main function, okay, we set I equal to 1, and then we create a new object n1, and you can see that there is no argument here, which means that the default constructor will be called. Okay, so number n1, and so this will create a object n1 and it will call the default constructor. So the default constructor will print 0. Okay, according to this. Okay, next what we are doing is we have a pointer number star n2, and we are creating a new object using this new syntax with I plus plus. So I plus plus, if we are using it, means that the the constructor will get the current value of I and then it will be incremented. So the constructor will get the value of I equal to 1 and then I will be set as 2. So here we will have I equal to 1 and then the new value of I will be 2. Okay. So since we have I equal to 1, it will print 1. And after this we have a pointer number star n3, but you can see that here that no new object is being created. Okay, we just have a pointer, but there is no object which we are creating. It is just a pointer which points to some garbage location. Okay, not really any specific location. So no constructor will be called here. Now in the last line we are again calling new number I plus plus. Now this is similar to that, so it will print 2 here. But this new object, it will not be assigned to any pointer. Okay, so this object will just be created and there won't be any reference to this object. Anyway, the final output will be 0 1 2. So that is the solution of the question. Now let us move to the next question. So please try on your own.
Uh, there is a error of parenthesis because the class member parenthesis is not correct.
Yes, hello.
Yes, sir. Sir, there is a parenthesis is not matching because the class parenthesis is open, but the closing parenthesis is twice. So there is an error.
Oh, sorry. Like I should have formatted it well. Actually, so this one is for this one.
Okay, sir.
Okay, please try this. Okay, now let us discuss the solution of this question. So, uh, so we have to fill in this blank such that the output is in C++ programming, and this is the class. Okay, and this is the main function. And in the main function, we are creating an object of this class with the arguments programming in C++. Okay, so this is the order. So now let us investigate the other functions here. So we have a function called mystr mystr dup. So mystr duplicate basically. So it accepts one string. Okay, it prints the string. You can see it prints the string, and then it calls the str duplicate function of C. Okay, so what this str duplicate function does, it is it copies the string. So this is a standard function. This is a standard function from the C string library. It copies the string. But here what we are doing is we are printing the string before copying it. Okay. And now we come to the constructor. So this is the constructor. In the constructor we accept three strings as argument, and then we have the initializer list. Okay, and in the initializer list we are copying each of the strings, and we are assigning them to uh, s1 s2 s3. So of course it means that we have to define the very data members s1 s2 s3. So here it will be const char star s1 star s2 star s3. Okay, so of course these will be there over here, but you will see that if we define it like this. Okay, s1 s2 s3, then the constructor is also s1 s2 s3, then of course it will print programming in C++ instead of in C++ programming. So the order of the arguments is The order of the arguments is programming in C++, but we have to print in C++ programming. So how do we change the order? We can change the order by rearranging the definition of these variables. So if we put one variable before the other, then the order will change. Why? Because the variables are the variables are initialized in the order they are defined in the class. Okay, it doesn't matter that how they are ordered in the initializer list. Okay, in the initializer list it's fixed, you can see it's s1 s2 s3, but they are actually initialized in the order they are defined. So since we would first like to print in, so we will put s2 first. Okay, this one will put first, then we have to print C++, so this s3 will go second, and finally s1 will be written here. So actually it will be uh, star s2, star s3, and star s1. Okay, so this is what we'll have to fill in the blank. Now I'll move to the next question. Please study this question. Okay, now let us discuss the solution of this question. Uh, so here we have a class test. Okay, we have a class called test, and it has a private data member underscore t. Okay, this is a private data member, and in the public in the public space we have two functions, set t and get t. Now set t is supposed to set the value of underscore t, and get t is supposed to return the value of this t. Now we come to the main function, and in the main function we create an object of type test, and then we uh, call obj.set t. So we set the value of t as 5. Okay, obj.set t 5, and then we write obj.get t. So this returns the value of the variable that we have set. Okay, so we would think that the output should be 5, right? But this is wrong actually, because note that the set t and get t, they have been marked as const. Okay, so what it means is that, like, if we write a const, uh, if we write the const keyword after the argument list, so this is the argument list of the function, right? And after the argument list, if we write const, it means that this function cannot modify the class, it cannot change the state of the class. So for the get t function it's fine, uh, because we are just returning the value of t, we are not modifying it. Okay, so this is fine. But for the set t function, this is incorrect, because here it modifies the value of t, so this will not compile. There will be a compiler error. Okay. So there will be a compiler error in this case. Okay. This is the new next question. Please try on your own. Okay, now let us discuss the solution of this question. So you can see that in this question we have a uh, class called complex with two private data members RE and IM. So again this tries to model a complex number. Then we have a constructor which takes two arguments underscore RE and underscore IM, and there is an initializer list. Okay, there is an initializer list where we initialize RE and IM with underscore RE and underscore IM. Okay, so this will go here and this will go here, and the body of the constructor is empty. Then I'll go to the show function, and finally I'll come to the change function. So in the show function we simply print the value of RE and IM, so there is nothing complicated here. Then we come to the change function. Now this change function is a bit weird because uh, it accepts a pointer. Okay, so this is a pointer to a complex class, a complex object. Okay, it accepts a pointer called new underscore c, and then it assigns this pointer to this. Okay, now as you know that this is also a pointer to a complex object, so this assigns this new c to this. Okay, so that is the definition body of the class. Now I'll go to the main function. So in the main function first we create a object c1 with the values 10 and 20. So it will re will be 10 and im will be 20. Similarly for c2 this re will be 20 and im will be 50. Then we are writing this line which is c1 dot change ampersand c2. So ampersand c2 will return the pointer of c2, right? It will return the pointer of c2, and then we are calling this change function with this pointer. Okay, and then we are writing c1 dot show. So this code it will actually create an error because the this pointer it is you cannot modify the this pointer. Okay, so as I said previously, so that this pointer it refers to current object. It refers to the current object from where the code is running. Okay, so inside c1 this will refer to c1. Okay, but inside c2 this will refer to c2. Okay, it always refers to the current object. So obviously it does not make sense if we can modify the pointer. Okay, because then everything will break, this whole concept will break, because so the whole concept will break. So uh, another thing to note is that what is the data type of this pointer. So in this case, since it is written in the complex function, so the data type will be uh, const. Okay, this is the data type. What it means is that what this means is that okay, no, sorry. Okay, so this is the data type of the this pointer. What it means is that the pointer cannot be modified. Okay, the pointer is a const pointer, which means that the the address where it's pointing to, that cannot be modified. Okay, this object c1 and c2, they are not const. Okay, the objects themselves can be modified, but like for example, you can write something like this. You can write this arrow x again, this arrow re equal to 2. Okay, so this is allowed because the c1 and c2 objects, they are not const. Okay, so you can write this, but you cannot write something like this. You cannot change the value of this itself because this is a constant pointer. So here there will be a okay, then so now I'm proceeding to the next question. And this one should be easy because I covered it in the previous question. So now let us discuss the solution. So we are defining a dummy class here because you can see that there is nothing inside the class. So uh, class, my class, okay, and then there is some code here which doesn't matter, and then we are calling the this pointer. Okay, now we come to the main function, and in the main function we have created a object of my class type called m, which we have defined as const. Okay, so now what will be the type of the this pointer? So according to the previous slide, okay, if our class name is my class, then the data type of this will be, okay, this will be the default data type of this. Okay, but now note one thing, that your m object, okay, m object is also const, so m object cannot be modified, so therefore another const will be added here before the my class type. Okay, so now the final answer is this. Okay, the final answer is this. So if you remember, like if you don't remember, then if you don't remember, then when you have a pointer like this and there are consts, okay, so then how do we differentiate? We suppose we have a integer pointer. Suppose we have an integer pointer, something like int star x. Okay, so then how do we say that what is const or what is the meaning of this? So what we do is we draw imaginary line. We draw imaginary line through the star, and if your const is on the left, then it means that x is const. Okay, it means that it does not mean x is const, it means that whatever it is pointing to, that is constant. So the point D, which is constant. So you have x which is pointing to some object. Okay, so this is your pointer and this is your point D. So if you have a constant here, if you have a constant and on the left side of the star, then it means that the point is constant. If you have a constant on the right side of the star, it means that the pointer is constant. Pointer is constant means that it always has to point to that same address. It cannot change the address where it's pointing to. Whereas pointy is constant means that the uh, this thing it cannot be modified, but your x can point to something else. Okay, that is allowed. You can also have both. You can have none also. You can have both also. If you write const on both sides, then it means that the pointer always has to point to the same location, and whatever it's pointing to, that also cannot change. Okay, so now let me move to the next question. So please try this. Okay, now let us discuss the solution. So we have a class here with some public constructors. Okay, So how do we know that it's a constructor? The class name and the function name should match. Okay, like exactly match. So the first one is a default constructor because it has no arguments. It has no arguments, so it's a default constructor, and it just it just prints O. Okay, and the second constructor, to it accepts a pointer to another data object. Okay, and it prints K. And the third constructor, it accepts a constant reference to another data object, and it prints Z. Now the last one, uh, it is a copy constructor. If you recognize the type signature of the constructor, then it's a copy constructor. A copy constructor will like if your class name is my class, then your copy constructor will always look like this. Okay, this will be the type signature. So anyway, this prints O, this prints K, and this prints Z. Now we come to the main function. In the main function, we create two pointers. Okay, we create two pointers to data type objects. Okay, and in the first pointer we assign as we create a new data object and we assign it to the first pointer t1. Then we this one will call the default constructor. Why? Because no argument is provided here. Okay, there is no argument in the function call, so this will call the default constructor. In the second case, we are creating new data, but we are also putting t1 as the argument. Okay, so now t1 is what? T1 is a pointer to data object. So t1 is of type data star. So it will obviously call the second constructor because this one the type matches. Okay, the type of the uh, constructor matches. So this will call the second one. Okay. Now in the next line, we are getting data t3 equal to star t1. Now t1 is a pointer to a data type. Okay, star t1 will give us a object. Okay, it will dereference the pointer, it will give us a object. So and then we are creating a new object. With this dereferenced object. So the copy constructor will be called. Okay, so the copy constructor will be called. And in the next line also we are writing data t4 equal to t3. Here see t4 does not exist before, right? So t4 does not exist before, so what happens is that a new object is being created with t3. Okay, so again copy constructor will be called. So the order is like this: the default will be called first, then the second constructor, and then the two copy constructors. Okay, so obviously then the answer will be O, K, and Z Z. So this is what will be printed. Okay, there is a question. The second and third method is ambiguous. Now the second and third methods, they are not ambiguous because the type signature is different. One accepts a pointer to a data type, and the second one accepts a constant reference. So since the data types are different, there is no ambiguity.
Sir,
Yes.
what is the reason that can T2 equal to new data T1 is not called the data const data address of T?
What? I did not understand.
Why the T2 equal ये T2 इक्वल न्यू डाटा वाली लाइन
Hmm.
डाटा कॉस्ट डाटा एड्रेस टी को कॉल क्यों नहीं कर सकती, ऐसा क्या कारण है, रीजन क्या था इसका?
अच्छा, क्या बोल रहे हो कि ये जो सेकंड मतलब ये वाला लाइन ना, T2 इक्वल टू
यस सर।
न्यू डेटा T1, ये
यस सर।
इसको कॉल क्यों नहीं कर रहा है कॉपी कंस्ट्रक्टर को?
कॉपी कंस्ट्रक्टर को कॉल क्यों नहीं कर सकती?
बिकॉज बिकॉज T1 एक्चुअली पॉइंटर है। T1 अगर एक्चुअल वो डेटा होता, लाइक अगर अगर T1 का डेटा ऐसे लिखा रहता तो फिर वो कॉपी कंस्ट्रक्टर को कॉल करता, बट
यस सर।
क्योंकि ये पॉइंटर है तो नहीं करेगा।
ओके सर, थैंक यू सर।
Okay, now we go to the next question. So please try this question. Okay, so in this question, um, do not print any character directly, such as do not print D or E, but instead try to use X to try to use the data member X to print uh, D. Okay, so you have to print D, so try to use X to print D. Okay, so this is actually a very quite simple question. Okay, um, so here we have a class string. Okay, and it has a private data member x, and in in the public scope we have a constructor uh, which accepts a character and it sets x to underscore x. Okay. Then we have a display function which our prints something. Okay, prints something here. And then in the main function creating a creating a new object small c, and we are initializing it with capital C character, and then we are calling c dot display. Now what I was saying is that in the program such that it will print d, but like do not, like you can of course print d directly over here, but try to use x to print d. So one way is this, that over here, since we have called it like this, so x is now set to c. Okay, so uh, like we can use that to print d also. So simply we can write here plus plus x. Okay, we can simply write here plus plus x because x is set to c. So if we write plus plus x, it will increment it to d and then print d. So this is a, so this is actually quite a simple question. Anyway, now let's move to the next one. So this is the next one. Okay, now let us discuss this question. So this is a bit complicated question involving constructors and destructors and the life cycle of the class. Okay, so we have a, in the global scope, okay, we have a variable I, static variable I, which is initialized to 5. Then we have a class. The body of the class is empty. Okay, there is nothing in, just we have constructor and destructor. So constructor, we know that it has the exact same name as the class as it's shown. Now a destructor also has the same name, but it has the tilde. Okay, it has a wavy sign like this. So it has a wavy sign like this, which is called a tilde. So the constructor is called when the object is created, and the destructor is called when the object is destroyed. Okay, so then we also have a function called check. Now note here that check is in the global scope. It is out, not inside the class. The class ends here. Okay, it begins here and it ends here. So check is a global function. And also note that check accepts uh, a data argument of my class type, and this is not a pointer or a reference. It accepts like the base data type of my class. Okay, then we have the main function, and in the main function uh, define a define a object of my class type called c1. Then we call the check function with c1, and then nothing else is done. So basically this question is about the object creation and destruction cycle. Okay, so firstly, like when the main function begins, so in this line the c1 will be created. Okay, so there will be a constructor call here. Okay, so because of that, uh, this one will be called I is 5, so plus plus I will be 6, so 6 will be printed. Okay, now what we are doing is we are calling check with c1, and note here that c in the check function, okay, the argument is not a reference or not a pointer also, which means that the argument will be passed by value. Okay, so this is a call by value. So when a call by value is done, the object will have to be copied. Okay, c1 will be copied into this c variable. Okay, now when it's copied, then the copy constructor is called. But here you can see that the copy constructor has not been uh, defined yet, so the default copy constructor will be called, which does nothing as such. So the default copy constructor is called, so let me write here. So the default copy constructor will be called in this line. Okay, but it will do nothing because the default constructor does nothing. Okay, now this code will run here, and when the code finishes, at this point the c variable will be deleted. So at this point the destructor will be called. Okay, destructor will be called. Now destructor, you can see it prints I minus minus. So I minus minus, what it will do is it will print the value of I, and then it will decrement it. So current value of I was 6, so 6 will be printed. So it was 5, then it became 6, and now it has again decreased, so it will now be 5. Okay, then the code will again return here, and when the main function finishes, it will again call the destructor. A destructor will again print the current value of I, and then it will decrement it. So current value of I is 5, so 5 will be printed. So the output is 665. Okay, any questions on this?
Yes, sir.
Yes, like say like what is the question?
Yes, sir. सर जब हमने एक ऑब्जेक्ट यहाँ पे बनाया है मेन में,
हाँ,
तब C1 एक बनाया है, तो सही वहाँ पे एक कंस्ट्रक्टर चलना चाहिए.
एक
तो
मिनट।
वहां पे सी आउट होना चाहिए प्लस आई 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 है 5, तो वहां पे सी आउट होना चाहिए 6 जब एक बना है माई क्लास वहां पे। उसके बाद से जब हमने चेक में C1 किया तो वहाँ कॉपी कंस्ट्रक्टर बना, जिसकी हेल्प से फिर से माई क्लास चलेगा, तो प्लस प्लस आई होके चलेगा, तो 6 के बाद 7 प्रिंट हो जाएगा।
क्या जिसके बाद में क्या होगा?
सर हमारे 2 ऑब्जेक्ट बने हुए हैं,
हाँ।
तो सही 2 बार इंक्रीमेंट होगा और 2 बार प्रिंट होंगे, तो 6 और 7 दोनों प्रिंट होंगे।
नहीं, दो बार।
तो हमें उसका साइकिल समझ नहीं आया।
हाँ हाँ। तो
और सर ये लॉजिक क्या है कि हम केवल 3 ही आउटपुट प्रिंट करें, क्योंकि यहाँ पे यदि 2 ऑब्जेक्ट बने हैं तो दो दो बार क्या बोलते हैं अपना कंस्ट्रक्टर चलेगा और 2 बार डिस्ट्रक्टर चलेगा। मतलब 4 ऑब्जेक्ट प्रिंट होने चाहिए, या तो फिर 2 ही आउटपुट प्रिंट हो या 4 हो, 3 कैसे हो सकते हैं?
हाँ, ये सही बोल रहे हो, दो ऑब्जेक्ट बने हैं तो दो बार कंस्ट्रक्टर दो बार डिस्ट्रक्टर कॉल होगा। लेकिन आ, एक में एक में तुम्हारा कंस्ट्रक्टर, मतलब जो डिफ़ॉल्ट कंस्ट्रक्टर है वो कॉल हो रहा है, और दूसरे में कॉपी कंस्ट्रक्टर कॉल हो रहा है। तो तो
यस
अगर
सर।
तो पहले था सी वन जब क्रिएट हो रहा है तो पहले चल रहा है डिफ़ॉल्ट। डिफ़ॉल्ट नहीं बोलूँगा क्योंकि मैंने ओवरराइट कर दिया था, तो पहले कंस्ट्रक्टर चल रहा है। फिर जब सी ऑब्जेक्ट बन रहा
यस
है तो डिफ़ॉल्ट कॉपी कंस्ट्रक्टर चल रहा है।
यस सर।
और फिर जब सी डिस्ट्रॉय हो रहा है तो फिर डिस्ट्रक्टर चल रहा है। और फिर सी वन भी जब डिस्ट्रॉय हो रहा है तो डिस्ट्रक्टर चल रहा है। ठीक है। अब
यस सर।
कंस्ट्रक्टर और कॉपी कंस्ट्रक्टर में अंतर है, ठीक है, दो दो अलग चीज़ है।
यस सर।
अब देखो, जो
ओके आई
कॉपी
अंडरस्टैंड सर।
कॉपी कंस्ट्रक्टर जो है वो यहाँ पे ओवरराइड नहीं किया गया है, ठीक है, तो वो डिफ़ॉल्ट वाला ही
ओके
होगा
सर।
जो कुछ करता नहीं है, मतलब कुछ प्रिंट विंट नहीं करता। और जो जो नॉर्मल जो कंस्ट्रक्टर है उसे हम लोग ओवरराइड किए हैं और प्रिंट कर दिए हैं।
यस सर।
ठीक है, तो
थैंक
दो।
यू सर, आई अंडरस्टैंड सर।
अच्छा, ठीक है। ठीक है फिर। सो दिस इज द लास्ट क्वेश्चन, प्लीज ट्राई। This is actually a tricky question, so please be careful. Okay, now let us discuss the solution. So the class itself is very simple. It's a point class with data members x and y, and then we have a constructor which accepts two values and sets the values, and it also prints the values. Okay, and then we have the main function where we are creating an object with arguments 2 comma 7. So ideally it should assign this 2 comma 7 here, so 2 and 7 should be assigned here, and then it should print it also. So 2 comma 2 and 7 should be printed, but the problem is that uh, this constructor is private. Okay, so what has happened is that, as I said before, that unless it's mentioned everything is private, so nothing is mentioned here. So since the access specifiers such as public has been not been mentioned, so it is private. So private constructor means that it won't be accessible from outside the program, meaning that this line is invalid. Okay, because we cannot access it from outside the program, so this line will give error. Okay, so there will be a error. Okay, so that is the answer. Okay, and that was the final question. So I would like to conclude the today's session. So thank you for attending.